Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. H of x equals x square into cos x, and we've been asked to examine the continuity of the function. So whenever you have a problem which is asking you to examine the continuity of a function, all that you've been asked to find is whether the function is continuous at all points belonging to R, and R is a set of real numbers, that is point one. And if it is not, then which is that point where there is a discontinuity, right? So those are the two important things that you will have to keep in mind when you're being asked to examine the continuity of functions. So we have h of x equals x square cos x, right? And uh, again, drawing your attention to the algebra of continuous functions, we know that if f and g are continuous at x naught, then the sum f plus g, the product f into g, the difference f minus g, and the f by g, all of them are continuous at x equal to x naught, except that for f by g, you'll have to remember that g of x not equal to 0, because f by g becomes undefined whenever g of x equals 0, right? So these are the fourth points that I would like you to remember when you solve these problems, right? And so you have, let us write down what is our f and g in this case, right? Seems like it is a product of two functions and two very basic functions, and so we'll have to identify what those basic functions are. So let's write them down. F of x equals, one is your x square and the other is your cos x, right? And so x square is a continuous function in the domain R, right? So and we also know that cos x is a continuous trigonometric function in the domain R, right? Now, so therefore x, both these functions are continuous, and we don't have a challenge in calling that belongs to R, right? So maybe I can write this. No, let me write it in the next line. So now I know that my f of x and g of x are continuous, right? And if I apply the algebra of continuous functions, then the product of these two functions, which is my h of x as defined originally, is also continuous, right? So therefore, the problem is quite simple. F of x and g of x are continuous at all x belonging to R. We know that h of x, which is nothing but your f dot g, is also continuous at all x belonging to R, right? I hope you found this video useful. Please do subscribe to my channel and support. Thank you.